Now that we know the SUVAT equations, let's learn how to properly use them. A particle moves along a straight line from A to B with constant acceleration 1.5 meters per second. It then moves along the straight line B to C with a different acceleration. The velocity of the particle at A is 1 and the velocity of particle at C is 43. The particle takes 12 seconds to move from A to B and 10 seconds to move from B to C. So work out the velocity of the particle at B. Okay, so first things first is I would always recommend drawing a diagram. So from here, this is A, right? I'll call this point B. I'll call this point C, right? What do we know? We know that the initial velocity U is equal to 1 meters per second. And we know that the acceleration is equal to 1.5 meters per second squared. And it takes 12 seconds, okay? So, how can we work out the final velocity? Well, we don't have a distance, so we have to use V is equal to U plus AT to work out what the velocity is, isn't it? So, we know that it starts with 1 meters per second of length, of speed, velocity. And we know the acceleration is 1.5, and we're timesing that by 12. So, if we plug that into our calculator, we should get a final velocity V of 19 meters per second. Okay? And so V at this point is equal to 19 meters per second. Now, how are we going to work out the final, the acceleration as it moves, as it moves from B to C? Well, one thing you need to notice, guys, is final velocity before equals initial velocity after, okay? So if this V is 19, now U is equal to 19 for this part. And this now T is equal to 10, all right? Because what is our final velocity going to be for this example? 43, isn't it? So let's write down 43 on this side. V is equal to 43. And we need to work out what A is. The way we work out what A is using the same formula. V equals U plus AT. But we're looking for A, so A is equal to V minus U over T. Okay? Our final velocity is 43. We're subtracting that by 19. And we're dividing it by 10. And we get an acceleration of, and you can plug this into your calculators, 2.4 meters per second squared. Okay? Now, how do we find the distance A to C? What we need to do is, because remember, the SUVAT equations only work if there's constant acceleration. Okay? So what we need to do is we need to find the distance here and the distance here. So I'll call this one SAB, right? And what do we know? We know the initial velocity, the acceleration, and the time. So S is equal to UT plus a half AT squared, which is equal to 1 times 12 plus a half times 1.5 times 12 squared. And if we plug that into our calculators, we should get an answer of 120 meters. Now we'll do the same thing for BC. So SBC is going to be UT plus a half AT squared. And so therefore, The initial velocity is 19. It takes 10 seconds. And the acceleration this time is 2.4. And t is 10 squared. So plug this into your calculators now, people. And you should get an answer of 310. So therefore, and I'll write this at the top so you can see it. S is equal to 120 plus 310, which is down here, giving us an answer of 430 meters. And that is your final answer. Is this video helpful? Well, make sure you subscribe so you never miss a video like it from me. Now let's look at this one. A particle P is moving on the x-axis with constant deceleration of minus 4 meters per second. At time 0, P passes through the origin with velocity 14 meters per second in the positive direction. The point A lies on the axis and OA is equal to 2.5. So the question is what is the difference in times between when P passes through A? Okay. So let's draw a diagram, shall we? If this is our origin and we know that it's going across the x-axis, this is our origin. And we know that the initial velocity is 14. Okay? Right? We know that A, it's decelerating, so it's equal to minus 4 meters per second squared. Yeah? Now what we need to do is model A over here. And A is equal to... Well, we know that the distance here is 22.5. Yeah? So, what we're going to do is we're going to use the SUVAT equations. That we're looking for the time taken. What do we have? We have a distance, we have an acceleration, we have an initial velocity, and we have a and we're looking for time taken. So S is equal to ut plus a half at squared. We're trying to look for the time, okay? So how do you think we're going to look for the time? What does this equation look like? Exactly, it's a quadratic. So therefore, half at squared plus ut minus s is equal to 0. And now we can plug in our values. So, minus 4 over 2 t squared plus 14t minus 22.5 is equal to 0. And so therefore t is equal to minus 14 plus minus the square root of 14 squared minus 4 times 22.5 times 2 minus 2 and minus 22.5, all divided by 2 times minus 2. And if you plug that into your calculators, you should get an answer of 9 over 2 and 5 over 2. Now I know what you're thinking, Sammy. Which one is it going to be, right? Because there's two answers and they're both positive. Remember though, it's asking you for the difference in the times. Okay? So therefore, delta t is equal to 9 over 2 minus 5 over 2, which is equal to 4 over 2, or 2 seconds. Does that make sense? So it's decelerating constantly, which means the particle is going to move something like this. Yeah? And this time here is 2 seconds. So now we're asked what is the total distance traveled during the interval between those times. Okay, so what we want to do is we need to work out what the final velocity is here, right? We want to work out the distance at which t equals 0. And then we work out the distance, and then we double that distance. So first things first, let's work out what this final velocity is. We have a distance, we don't have time. That's the only thing we don't have between this area, okay? So, v squared is going to be u squared plus 2as, which is equal to 14 squared minus 2 times minus 4, plus 2 times minus 4 times 22.5, right? Plug that into your calculators, and you should get an answer of 16 meters per second all squared, right? So therefore, v is equal to 4 meters per second. So now what we want to do is we need to realize, what is the velocity here going to be? 0. Why? Because it's decelerating and then it's turning the corner. So we now know that our velocity is 0. So all we need to do to work out that distance is the same formula. V squared equals u squared plus 2as, right? We know that v is equal to 0, so u squared plus 2as is equal to 0. So how do we find out what s is? S is just going to be u squared over 2a, all right? Or minus that, actually, but you know what I mean. We know that remember what we said, final velocity before is initial velocity after. So this is going to be minus 4 squared, all divided by 2 times minus 4, right? And that should give us a distance of 2 meters, okay? Remember though, it has to get from here and then back, okay? So therefore, the total distance is going to be 2 meters times 2, which is equal to 4 meters. And that is your final answer for part B. Still stuck on these sorts of questions? Well, make sure you join my Discord server down below for responses to your questions. Now let's look at this example. A particle is moving along the x-axis with constant deceleration 5 meters per second. T equals 0. The particle passes through the origin with 12 meters per second. And at t seconds, the particle passes point A with x coordinate 8. So find the values of t. Okay, so it's very similar to the other question. We know that this is 0. We know that u is equal to 12 meters per second. And a is equal to minus 5 meters per second. And we know that this is at point 0, 8 meters. Just for the sake of argument, let's use meters, okay? Now, how are we going to find out what t is? Well, it's exactly the same as what we did last time. S equals ut plus half at squared. So therefore, half at squared plus ut minus s is equal to 0. And so therefore, let's plug in our values. So minus 5 over 2 t squared plus 12 t minus 8 is equal to 0. And so therefore, we'll write this in a different color. T equals minus 12 plus minus the square root of 12 squared minus 4 times minus 8 times minus 5 over 2. All divided by minus 5. Okay? So if you plug that into your calculators, you should get an answer of 4 and 4/5. Okay? So those are my values for t. Now, what is the velocity of the particle as it passes through x with coordinate minus 8? So, the first thing we need to know is what is the distance at which it changes direction? Exactly. It's the point at which v is equal to 0. Yeah? So what we can do, because we're trying to work out the distance between here and the point at which it changes direction, v squared is equal to u squared plus 2as, right? We know that v squared is equal to 0, so s is going to be u squared minus u squared over 2a, okay? So now let's write that down. That's going to be minus 12 squared over 2 times minus 5. So we should always get a positive value. And if you plug that into your calculator, you should get an answer of 14.4 meters. Now what we need to do is let's draw another diagram. Okay, so this is the point. I'm going to call it point B, right? And we know it's at 0. No, it's not at point 0. Sorry, this is the wrong way around. But I hope you understood that. So that's 8 along the corridor up the stairs. And so this is 14.4. What is the distance between here and minus 8, 0? Exactly. It's going to be this minus this, right? Which is just going to be 22.4, okay? Now, we know that this time the deceleration is going to be an acceleration of 5 meters per second squared, okay? We know that we're trying to look for the final velocity. And we know that u is equal to 0. Why? Because final velocity before is initial velocity after. So, how do we work out what v is? V squared is equal to u squared plus 2as. And so therefore, v is equal to 2 times 5 times 22.4, which is 224. And so v is going to be the square root of 224, which is equal to 14.97 meters per second. And those are your final answers. Thank you guys for watching. Sorry this video was a bit longer than I wanted it to be. Do you guys want to pass your exams with flying colours? Well, you can get tutored by me. Drop me an email for a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.